everybody. Just a few words on me before starting. Okay, I'm not an engineer. Okay, but I studied mathematics, so I have a different theoretical background, and I work in image and video authentication topics. Okay, I work with the University of Florence for several years, and in project funded by the European Commission and DARPA, for projects related to authentication and reverse engineering of multimedia content. Being in the university, I worked a lot in research, so I'm also co-author of several papers in peer-reviewed journals related to multimedia forensics in general. Okay. And I have also experience as an expert witness in multimedia forensics in Italy. I think this was really useful for me because I was able to look at a different point of view, because this topic put together scientific research, so very technical issues, together with the need of people to understand and to use these tools and to explain them in an easy way. Okay, so we need to know both words of both sides of the words. Okay, before starting, I would like to understand why we are making this webinar, and the main issue related to the spreading of these new technologies to create good manipulation, even if you're not an expert. So you can use text-to-image tools, you can ask everything, you can create good manipulation, you can edit some specific pieces of the image and create very, very realistic manipulation. On the other side, we really rely on our eyes and on our senses to determine what is real and what is not. But based on our experience, we noticed, and based on some tests that we are doing, we are noticing that people is not so good in determining what is real and what is fake. Okay, so just to give you just an example, okay, here we have a couple of images, and if you want to guess, okay, which is real and which is fake, you can try. And as Michelle was saying, you can try also answering in chat just to share what is your feeling, okay? Because now we are able to create high realistic images, but sometimes we can make confusion, for instance, between what seems synthetic and what is with high resolution, high details, and so on, okay? So just 10 seconds, you can try to guess, and then we will see another example, and then we will try to build the need that we have to have available several tools to determine what is real and what is fake. So I see maybe there's, okay, there is some answer in chat. Okay, just take a few seconds more. I keep going. I don't know who got them. Okay, but one is real, one is fake. And don't worry if you made a mistake, because we do not expect that people is really able to guess it. Just make another example, just to have fun and understand how our brain works when trying to determine what is fake and what is real. Let's make this other example. You know, we are Italian. We like to eat good food, drink good coffee. Okay, so we also need to take a lot of pictures to invite you to drink and to eat in our restaurants. Okay, so again, you can try to determine if they are real, if they are fake. I understand they look good. So just a few seconds more. We don't really need to understand now if we are good or not, okay, because we are just two samples. But I think it's good to understand how our brain works when trying to say, okay, is this coffee real or is it fake? How I decide it? Do I decide it based on the quality, based on the details, based on the resolution, based on the contrast, or based on something else, okay? And as you can see, we can have very different opinions, and we take time to decide, okay? So in this case, unluckily, they are both fake. I'm sorry for that because they looks very good, okay? But these examples are just to show you that it's very hard. We made a big test on this with the 20 images, okay? And we asked people, we don't care if they are naive or they are extremely expert in multimedia forensics, okay? We asked them to choose between, to decide if the image is real or not, just based on our visual analysis, okay? Here's the result that we achieved until now. As you can see, we have from 0 to 20 positive guess. And as you can see, the distribution is that we have, in average, 10 on 20, meaning that any people get half of the result correct. Okay? So it's like flipping a coin. Okay? This means that, unluckily, okay, we are not so good in determining what is good and what is fake. Okay? If you think you can do something better, we would really appreciate if you can try the test and see if you can achieve something better. Okay, you can scan this QR code, or maybe Michelle, if you can also share the link on the chat. You can make the test and see, don't worry, it's completely anonymous. So the test will only store the score. And of course, we'll provide you the score. Okay, so it will tell you which is your score. Okay, so it's good to understand how good we are. Okay, and the truth is that we are not good. Okay, unlucky. Okay, that's why this is our starting point. That is, we are not good in determining what is good and what is fake, what is real and what is fake. So what this webinar is about, we show some new techniques that can be used to authenticate images. Okay, since this topic is very tough, okay, we also need some background information. Okay, so we need to show at least the basics, okay, on or the principles on how we will work in for image authentication in different cases, and then we'll open Authenticate and we'll see the example in practice. Okay, so of course we will not go in the details. So I will try to find the balance between explaining the basics and the principles, but we cannot go so much in the details, okay? Because there is a weak course on these topics, okay? So we'll try to find the balance. Furthermore, we will see how to combine different tools, okay, to provide a lot of information related to the image lifecycle, okay? And we also see how to describe and properly interpret some results that we can achieve from our forensic analysis. Okay. Please feel free, of course, as Michelle was saying, if something is not clear, if you're curious, or if you want to share your experience on some topics like this, you can use the chat. Don't worry. I will try to answer in the end. Okay. So, which is the main forensic principle? Okay. When we take a look at an image, okay, if we are naive, we just look at the image content, okay, the visual content of the image. Okay. But if we are forensic expert, we need to remember that behind the image, there is a huge amount of information, because the image, first of all, is a file, a digital file, that has a container. It's a package of data. Okay. This package contains data in a structured way, okay, depending on the type of file. Okay. Furthermore, within this package, that we can imagine like a box containing things, okay, we need a list of information related to the data. Okay. And these are the so-called metadata. Okay. It's like a list, textual information related to the image content. Okay. So for instance, if we acquire with a specific camera we expect to find in this textual information, for instance, the brand, the model, the acquisition date, maybe the GPS coordinates, the technical specification of the lens, the firmware, a lot of information. Okay? That can be used, of course, to analyze the image and to see, to check the consistency between this metadata and the image content. Then we have some more advanced information that are called coding information, that are the one that are needed from our computer to decode the image and to read it. Because image pixels are generally not stored in the data, okay? But we encode them in a specific way, and then when we double click with our computer, with our mouse, the data are decoded based on the coding information to show the image. This coding information can be customized based on the brand or the model or the specific software used, so they can leave huge and relevant traces to understand the image lifecycle. Finally, last but not least, the pixels. Okay, but not the decoded pixels, but the encoded pixels. So it's a data stream that is encoded based on the coding information. So we have a lot of information available to analyze the image. So how can we use them? When we have a user, a malevolent user, that tries to edit or synthetically create a digital image, what happens? All these data are can be modified, can be partially created, can be partially deleted. Okay. So, for instance, if you modify an image with a software, some metadata will be changed. If you create an image with an AI-based system, some metadata can be created based on the system that you're using. If you manipulate an image with a standard software or an AI-based software, after that, you need to save the image again. So you're altering the coding properties, the compression parameters of the image. Furthermore, if you modify some specific portion of the image, for instance, if you want to remove a part, an object, or you want to modify a face, you are altering the pixel statistics. Because when you acquire an image, the process of the acquisition introduces several correlations among pixels. Then, when you modify a portion of the image, you are altering, removing, or adding some specific artifacts or pattern. Okay, so you can add correlation, remove correlations, remove sensor pattern, and so on. Okay. Furthermore, the image, even if we exclude the digitalization, so the digital domain, we have to remember that an image is a 2D representation of a 3D scene. Okay? So when we acquire a 3D scene onto an image, okay, we apply some projective transformation that are subjected to geometrical rules. So we expect that some shapes must satisfy some rules. Okay? Shadows must be consistent according to specific rules that link the light source with the cast shadows. The reflection must be consistent. Okay? The perspective must be consistent. And similarly to the previous example that we made, we are not so good in determining if the perspective is correct, if the light is consistent, and so on. Okay? So we have a big world of things that we can analyze. Okay? So rather than taking a look at all these things, we start from some cases, quick cases. Okay? So we will touch some advanced tools that we released in Authenticate, okay, together with other available tools that can be combined with them to provide a much more reliable information and findings on the image. So let's start. Let's suppose that this image is provided. Okay? And this image is supposed to show a famous person at a specific moment in time. So we want to use this image, okay, as an evidence, okay, that that specific person was there at that specific moment. Okay. So let's try to analyze it. And which are the tools that we need to use in this case? We'd like to understand if the image is native, is reliable in the content. Okay, so it hasn't been modified, if the metadata are reliable. So we can go and check. Okay? For instance, if the image is expected to be captured from a specific camera, and we'll see in the metadata, we will find some specific camera. Okay? Then we expect that if the image is native, we expect a specific resolution, some specific metadata. We expect to have the creation date, the modified date. We expect to have some compression schemes that must be consistent with the specific brand and model. We expect to have a specific file structure given from that brand and that manufacturer. Okay. And how can we analyze this? Because of course we cannot have the experience of knowing all these details for all the models. Okay. In Authenticate, we can exploit two tools. Okay. One is to use an internal database. Okay. We have a lot, for more than 14,000 images belonging to different models, reference camera, and so on, that can be compared with the questioned images. But we can also use external services to download images and to filter those images based on some parameters on our questioned image. Okay. So to find images that should have the same structure of the questioned image, and then we can make decision. Okay. So let's try. We open Authenticate. We load our first image. Just a second. Okay. Let's go and check immediately the metadata. So I go in the metadata and I can see clear traces of expected original metadata. For instance, I can find specification of the lens. It means that this belongs to an iPhone 13. And we see that this image is full of metadata. We can also check, for instance, if the modified date and the created date are the same. And as you can see here, modified date is the same as created date. The image is supposed to belong to an iPhone 13. So metadata seems to be consistent with a native image. Okay. But let's go deeper. Let's go deeper. For instance, let's take a look at the thumbnail. We know that when you save an image, within the image itself, we save other small images that can be useful when, for instance, on our computer, we need to see the preview of the image, so you don't need to decode the whole image, okay? So you have these smaller images that can be decoded, so the thumbnail, the preview. So let's check the thumbnail of this image. If I check this thumbnail, I can see that the content of the thumbnail that is supposed to be the same of the image content is very, very different. So I think this is a huge problem for the integrity of this image. Maybe the only check that I would do is to verify if this could be a bug of the firmware. So something that I can do is to download through, for instance, in Authenticate, we can download similar images from Flickr and Camera Forensics, okay, belonging to the same model, to see if this may happen. Okay. And I already did this. I found a few of these images, so I can load them as reference. I can see, for instance, that in this case, I have a thumbnail, and the thumbnail, of course, has the same content. Then I can compare again the EXIF metadata. But I don't find something really, really strange. I mean, there are a few differences that should be explained, but the question is not clear. The problem is not clear. So I can do something else now. If I check the EXIF data, I also notice that we have GPS coordinates. So I can try to see where this image has been captured. It's easy with Authenticate because I can go in Tools, I can show image location on Google Maps. And I can see that this image has been captured here. We are at Budapest, so we can go here with the street view. Okay, here. Now, this suggests me something, because if I look at the thumbnail, it seems that the content is very similar. So let's open again. Let's open the thumbnail, and maybe I can remove this image. And I can see that here I have a river, maybe here I have a bridge, and here some stone, I don't know what, maybe a statue, I don't know what is this. And if I check again, I can see that I have the river, the bridge, and possibly the statue. So in this case, I verified that the GPS coordinates, so the metadata, are strongly consistent with the thumbnail, so this hidden content, that is very different from the original content. So this result, in my opinion, at least, based on my expertise, strongly support the hypothesis, of course, that the image is not reliable at all. Okay. And maybe one explanation could be that we took an image, then we copied the metadata of another original image on this, on the questioned image, but for mistake, of course, we also copied the thumbnail. Okay. So we have and this would justify the fact that the GPS coordinates of the metadata are strongly consistent with the thumbnail rather than with the image content. So this is just an example on how we can combine several tools, even available tools, okay, to determine if an image has been modified or not. So in this case, we noticed that the model was not compatible with some metadata that we found. We saw that the thumbnail content is different from the image content, and we verified that the GPS location was consistent with the thumbnail rather than with the image content. So we can say that the image is unreliable. Okay. Of course, thank you. This is something that can be definitely done based on I'm reading the question of Anthony, okay, that suggests that we could also check position of sun if it is consistent, of course, to verify that it is consistent with the thumbnail. I would say that it is enough to say that the image content is not reliable. And unluckily, if we had more background on the questioned image, maybe we could also make some observation on the sun position and the GPS position in relation with the questioned image. So thank you for noticing, Anthony. Okay, let's move to another case in which we will try to combine available technologies, available authenticate technologies with new interesting tools. So let's say that now the question is very clear and it's very trendy. Okay, so is this image synthetic or is authentic? Okay. So how can we work? The dream of everybody is to have a tool where you can drag and drop the image, and the tool will say, don't worry, it's synthetically generated. Okay, period, and you're done. Okay. Unluckily, it can't work like that for several reasons. But we can certainly use a deepfake detector, okay, to determine if there are some compatibility in the low-level traces of the image. We can determine if we can find the footprints of some synthetic generation models. Okay, so this is one key point. But there is also another point. We have reflection. So reflections are a very peculiar thing to find in an image. Okay? And based on what we were saying, this reflection must satisfy some geometric rules. I'll try to explain in one slide, which is the principle. This is an image, an original image with an original reflection, of course. So what happens? Let's take a look at this drawing here. Okay, we have an object that is reflected through a mirror. Okay, so when you look at something through a mirror, it seems that the object is on the other side of the mirror at the same distance from the mirror. Okay. So if you connect any point of view with your mirrored part, okay, you will have lines that are all parallel because they are all orthogonal to the mirror. So when you acquire these parallel lines through your camera sensor, you have that the parallel lines will converge in the image. For those of you who are familiar with vanishing points, this is very trivial. Okay. For those of you who are not familiar, please, you can simply think when you drive on the street. Okay, the lines on the street are parallel in the 3D world. But if you look at them in your image, on your eyes, you will see that these lines will converge. It's exactly the same principle. Okay, so you have parallel lines in the 3D world, but you have a vanishing point, a converging lines in the image. So you expect that in this image, for instance, if you connect the ear of the girl with the reflected ear, the line connecting these 2 points will intersect the reflection vanishing point. So this means that if I connect several points with their reflections, all these lines will intersect in the vanishing point. Okay, this is in theory in the analog world, okay, but since here we are in the digital world, we have that we can select a point up or down, and maybe different expertise would choose slightly different points. So how can we solve this issue in the forensic world to guarantee repeatability? We say, okay, let's take this, let's consider the hair here, this edge of the hair. Then we'd like to connect this point with the corresponding reflected point of the hair. But which one? Okay, we select a wedge. So we select an interval, and this determines a wedge, okay, in which we should find the reflection vanishing point. So if we do this with several points with their reflection, and we intersect all the wedges, in the end, we expect that the intersection of all the wedges will contain the reflection vanishing point, okay? Yes, this image is real. Sorry, I'm reading the question. It's real. It's just to show how it works. Okay. Indeed, in this real image, the reflection vanishing point is contained in this yellow region. So if we find a wedge that is incompatible with the intersection of all the other wedges, this means that the image is unreliable because it does not satisfy the projective requirements. Okay. Okay, a long explanation to try it on this image. Okay, so here we have a couple of tools. One very advanced tool for diffusion model detection. The second, model-based, for detecting the consistency of reflection in an image. And then we can combine these results. So let's open the second image. Okay, first, let's open the diffusion model deepfake detector. Okay, this tool is designed to detect images that are compatible with any of the most famous diffusion model. Okay, that is the most important technology to create the so-called deepfakes. Okay, so we use it. Okay, and as you can see, the system is trained to some of the most famous diffusion model-based tools for generating images, like Stable Diffusion, DALL-E, Midjourney, and Flux. Okay. So here you have a result of compatibility, okay, with any of these models. Plus, of course, not compatible with unknown diffusion models, because since these tools are data-driven, we must remember that if a new tool appears on the market, okay, and the detector is not still trained on it, okay, maybe it is not able to detect that specific model. Okay, so in this case, we expect that the image falls in the not compatible with no diffusion model. That means that the image can be AI based with some unknown models, or can be real. Okay, but in this case, luckily, we see a strong, very strong compatibility with Midjourney. So it's 0.97. Okay, we shouldn't read this like a probability. Okay, it doesn't mean 100%. I mean, it's almost sure based on the tool. Okay, but we can say that the tool is strongly confident that we have a huge compatibility with this tool, between the questioned image and Midjourney. So this is a huge clue. Okay, we try to combine this with the reflection analysis. So we can open the reflection. I already started it, but we can do it together. We can reset the project. Okay, so how it works. Let's say that we have, okay, let's start with some points that we can connect. So I would say the lips, maybe the corner here of the lip. Let's say from here, I don't know. We can connect this, I don't know, here, or maybe here. Let's create a wedge like this. Okay, now we know that the vanishing reflection point should be somewhere in this wedge. Okay, let's do the same with other points. So maybe we can go with the eyes. Let's start from the corner here of the eye. We can link, I don't know, here or here. Okay, there is a question. Is there a certain numerical range that we can trust? Not exactly. I mean, this technology allow you to decide which is the range. I mean, if you are unsure, you can do like this, okay, and say, with this, I'm sure. Okay. Maybe we can delete this. Okay. That's why we have wedges. Okay. So now I would say something here. Yes, I can show how to make this line, because now we can choose another point. Let's use this connection point here. So I'm looking in the middle of the mouth, let's say here, okay? So this point is the reflection of this point. But which exact point? To avoid misinterpretation, it is good to decide a wider wedge So to be sure that the corresponding point is contained within it. So like this. Now, as you can see now, the system became unfeasible. And furthermore, I can keep adding points. For instance, if I select this point here, this should be connected to some point here, with some point in the external side of the arc. So maybe between here and here, I don't know. But okay, the system is already unfeasible. Okay. So until we have, let's say, a couple of points like this, we can see the feasible region, meaning that we expect the reflection vanishing point to be somewhere here. When we put too much constraints, if the image is real, we expect to have the intersection. Otherwise, we don't. So in this case, we can see that the reflection is, technically speaking, inconsistent. So this is a huge clue, because although we have that the deepfake detector is sure or almost sure that this image is synthetically generated, okay, if I have to go to court, okay, on one side we have the tool that is very effective because it gives you the answer, okay, but the inconsistency of the reflection is extremely powerful because it is model-based, it is easily explainable, okay, and on this side is a stronger weapon to say that the image is inconsistent because it's not data-driven, but it's model-based. So, very useful to see how we could combine these new tools, okay? One that is focused on AI detection. Okay? The other one that is more general, analyze the physical inconsistency, but is also model-based and has a strong background, okay? This specific tool we made a lot of tests and a formal description of the reflection inconsistency analysis. And these results are published also in a paper that you can find in the slide, where we also discovered that different synthetic generation model have different capability in generating consistent shadows and reflections. Okay? So the answer is that yes, it's fake. Okay. Just to summarize what we understood on this example is that AI-based tool, like the physical-based tool, cannot really provide a probability. It's up to our expertise to combine the results and decide which is their weight, okay, in deciding the answer. Okay. Furthermore, especially for the data-driven tools, okay, we have to remind that if you are taking an image from the wild, okay, from anywhere, okay, we should consider that the AI-based tool, okay, the data-driven tools in general, can lack of some information. Okay, so we should take care in using these results in general. While the physical-based tool is extremely effective, independently on the compression, independently on the image life cycle. So if you find an inconsistency, it's a physical inconsistency, has a model-based, so boom, you are done. Okay. Even if it's more generic, okay, you cannot say it is generated with Midjourney. Okay, so different tools provide different information that can be combined for an overall result. Okay, this is what we already said. This is just a note that we'd like to share because it's important to be informed when we use any data-driven tools, okay? Remember that when you have numbers that describe a confidence or a compatibility of that is the output of a tool, they cannot be generally linked to probability, okay? So if we have a tool that provides 0.9999, okay, it doesn't mean that we have a probability almost 1. of something, okay? So the short answer is that we can never link this output to probability. But if you're curious, we had a long webinar on this, so you can scan this QR code and then you can take a look to it, okay? So it is generally recommended when we use any tools, okay, to provide, to use compatibility related words rather than probability, okay? To avoid the misleading results and sometimes also big mistakes, okay? Because the tools work well, okay? We have to work well also in the interpretation. Okay, let's make another example. In this case, I would like to start from the ground truth, okay? So we see how the manipulation is built, okay? And then we see how to detect it. Okay? I think this is really interesting because it is good to see also how images can be created to create a really, really realistic manipulation. So let's use an image, a text-to-image tool. Okay, means that you have a prompt, you put a prompt and you say, please imagine this, okay? And the tool provides you the image. So I want to imagine a group of refugees facing the sun, and here's the result, okay? But now let's say I want to modify the information within this image, okay? So I'm not satisfied and I add the prompt, please add a tent in the upper left corner of the image. And the tool, boom, adds the tent. I'm not satisfied yet, maybe with the identity of the person in the center. So I ask, please add a woman in the middle with a different dress. And boom. Okay. So now this is the fake image. Okay, we don't care exactly what we'd like to explain with this image. Okay. So how can we analyze this? Of course, by using a deepfake detector, but also in this case, but also in this case, I can notice that we have shadows. So here you can see these people with cast shadows, and also the woman has a cast shadow here. So can we again combine deepfake detectors with shadows analysis? Okay, let's go and check this out. So again, I will try in one slide to explain how this works. So the main principle is that if we have a light source and then we have objects here, the cast shadows are built in a specific way. That is the following. If you connect the light source with any point, okay, the connecting line will also intersect the corresponding point of the cast shadow. Why this is very, very useful? Because if you link a point with its corresponding point of the cast shadows, the line will also intersect the light source. So if you do this with the several points and their corresponding cast shadows, in the end, you expect that their intersection, in a real image, of course, will intersect in the light source. Okay, this is a case, a very trivial case, okay, in which we connect cast shadows with the corresponding points. And as you can see, we almost get the light source. This is useful similarly to reflection because it is explainable, okay? It is model-based, and it's also immune to compression because even if you have a very low resolution image, strongly compressed image, this is a geometrical property. This means that it still stands after the compression. Let's make an example on how it can be used to detect deepfakes. Okay. So, for instance, if you have a real image, again, similarly to reflection, we're not using lines, but we are using wedges. Okay. So to avoid misinterpretation or disagreement among experts. Okay. So here you can see that the region, okay, contains the light source. Let's take this mid-journey image. if we consider the brush, the people, and their corresponding cast shadows, if you intersect the wedges, you see that you can find an intersection. So in some way, Midjourney is creating a sort of consistency in this image between shadows. Unluckily, Midjourney still doesn't know that the light source should be in this intersection. So in this case, we can get that the image is not reliable. So in this case, I'm not opening Authenticate, okay? In this case, to save a bit of time. But if you analyze the cast shadows, so you create the wedges here, 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 and here, you will find that there is no region, okay? So again, in this case, we have two different tools. The physical-based tool that is saying, okay, the image is not reliable, plus the deepfake detection tool that is saying that the image is a deepfake. Maybe we can check what Authenticate says about this image. Now, as you can see, also the image is strongly compressed here. I think this is not the original image, but it's a recompressed way. So let's see if, okay, we are lucky, meaning that Authenticate still find traces, okay, of synthetically generated images. Okay, so as you can see, it finds us high compatibility with Flux. Okay, so on one side, we have a strong hint that the image is synthetically generated or manipulated, together with a model-based tool that is strongly effective in give reliability to your results. Okay. I see a long question. Maybe I will read later, if it's okay for you. No, a lot of questions. Okay, so please give me some minutes, so I will close and then we'll try to answer them. Okay. Now, since this webinar, I mean, is more designed to understand how we can use filters and advanced tools, but if you want, you can check on the blog for other tricks to spot deepfakes. Okay, you can scan this QR code because there are several, let's say, bugs, okay, that can allow us to detect if an image is generated by a specific architecture, okay, because they have some specific defects, okay. Okay, let's make one last example that is related to checking integrity of an image. Okay, so we have this image and we are asked to determine if the image is camera native or it has been processed in some way. So is the content reliable or not? Again, here, I would like to show you another advanced but very generic tool. Okay. So we need another piece of theory that we'll try to summarize in one slide. That is, when you acquire an image, okay, when you click on your smartphone, several things happen in your camera. Okay, so the 3D world passes through the lenses, the optical filter, a color selection pattern, then the image is digitalized. So we have sampling, we have interpolation of the colors, we have in-camera software processing, we have a specific compression pattern, we add specific metadata, and so on. And in the end, we have our image. Why this is important? Because all these pieces leave specific clues in the digital image that can be used to verify if the image is native or not. So if the image is native and it has never been touched, we expect to find exactly those traces. Then, if you modify the image in any way, you will apply some additional processing. So for instance, you remove something, So you are changing the statistics there, or you are resampling the image, or you are adding things, or you are cloning things in the image, or you are changing a face. So you are processing a part of the image, changing the statistic of the pixels, changing maybe the perspective, if you're changing the position of some objects, and then you need to save the image again, meaning that you are applying a further compression to the image. This means that you are partially deleting the traces of the original image. You are adding some specific clues that are related to your processing and to the manipulation itself. So during this process, we delete original traces, we add some other traces, and this is extremely useful to check the image integrity, especially because if you manipulate an image and you compress it again, you have an image that has been subjected to compression because you acquired it, manipulation, compression. So when you have a manipulation between two compression, we don't care if you use the most reliable and effective AI-based tools. There are some technologies that allow you to spot it independently on the technology. So let's check how it works. Let's open Authenticate and let's load this last example. Okay. Of course, we can try to visually analyze this image. I see here something strange, but I don't rely to my eyes. Okay. So first of all, we go in the metadata. Okay. First file format, and Authenticate quickly give me some hint on where to start. Okay. First thing to be noticed is that the create date is different from the modify date. This is immediately a hint that the image is not native. Okay, but we know metadata, are reliable. But okay, let's start from here. Okay, then we see that the image is expected to belong to a Google Pixel 7a. We have an unexpected compression scheme. Okay, so let's open the compression schemes. And here, Authenticate provides, based on the database that we have available, which compression schemes are compatible with the one of the questioned image. So we have thousands of images belonging to several models, and we find compatibility in the compression scheme between the questioned image and these models here. So as you can see, we can also find here a Google Pixel 4 XL. Okay. We don't have in the database Google Pixel 7a yet, but it seems that the compression scheme is compatible with the Google Pixel. So the compression is compatible with the Google Pixel, but the image has been processed after the acquisition. Which could be the reason? Okay, let's take a look at the metadata. Now we'll go quick. Of course, the analysis could be longer if you don't know where to look at. Okay. Let's take a look at the metadata. And oh, here I see edited with Google AI. Okay, so this is a hint that or within the camera or after the modification, the image has been processed in some way. So we don't know exactly what happened, but we have now to hint that the image has been processed, okay? And maybe it has been processed with Google, maybe, we don't know. But if it has been processed after the acquisition, it means that the image has been compressed twice. If it has been compressed twice, we expect to find some anomalies. Okay? Of course, we would need the full course, okay, to understand which anomalies we should find, okay? But I will show you, and I will quickly explain. When we look at an image, in the frequency domain, okay, we can see this kind of plot. When the image is compressed twice, we expect that this plot expose peaks and valleys. Like here, as you can see, we have peaks, valleys, peaks, valleys. So it's exactly what I expect when I see an image that has been compressed twice. Okay. So this is another strong hint that the image has been compressed twice. So we are building the story. The image has been acquired. Then since the modified date is after the create date, it means that something happened, maybe with Google AI, because we read in the metadata, and then the image has been compressed again. So we have two compression, and this is confirmed by the analysis of this DCT plot. If it has been manipulated in the middle, we can use a tool that localize manipulation when an image has been compressed twice. And remember, I don't care if you used AI or not, because this tool analyzes the inconsistency between the two compression. Okay, so it is robust to any AI technology in this sense. So let's try to use it. It's the AI AD JPEG. Boom. Very clear. We can find a piece of the image with a compression scheme that is completely inconsistent with the rest of the image. If we swap, okay, now that I have the hint of the software, maybe I can go and visually see if I see something strange. Let's go like this. I have to say that visually speaking, I cannot see. Yeah, maybe here I can see some traces of compression, some edge, some strange edge, but I couldn't say that this is manipulated from these edges. Okay, but luckily, this tool that is very effective, especially when the compression quality is high, expose that the image has been likely processed in this part. Okay, so again here we combine things to reach a rich explanation on the life cycle, okay, of the image. And just to summarize, we analyzed metadata. We saw that Google AI was used and that the image was modified because we have modified date after creation date. The frequency analysis reveals traces of double compression. And then the manipulation was detected through the aligned double compression JPEG. We also find the original image. And as you can see, we had this thing here. This case is very interesting because we were able to determine even a small manipulation. Okay? This is not always the case, of course. It depends on several factors. Okay? In this case, the manipulation was made after the acquisition, okay, through some internal software. Okay. So within the smartphone, okay? So we didn't go outside of the smartphone. But please remind that we start seeing that AI processing sometimes happen inside the camera. So within your click, you also have some AI-based processing. That's why we shouldn't rely only on tools, but we also have to use our knowledge to understand the background information and see what to expect. Okay, I just give you a couple of questions, a couple of examples. So one is this Samsung phone that uses this super resolution and scene optimizer, where you get an image like this that you see here, but then the optimizer provide a very, very detailed image. So are these details real? Who knows? Okay, it's not the topic of this webinar, but it's something that we should consider with attention. But another clear example is that, again, Samsung Galaxy S23 with this remastering feature, okay, we got this picture and then the tongue was changed into teeth. Okay, so of course this is a change of the meaning of the content, but the image, technically speaking, is camera native. So which is the boundary between integrity and authenticity? Okay, is something we should consider, because this boundary is getting thinner, okay, and thinner. Okay, so just to summarize what we did, okay, we analyzed a number of cases, okay, and we saw that in each case required some specific weapons, okay. Luckily, Authenticate is well equipped, and we keep updating it with the most advanced tools, okay. And we saw cases in which, for instance, we found inconsistencies between the metadata and the image content, because we had a hidden content with the GPS coordinate that were consistent with the hidden content, but not related with the image content. We saw a couple of cases in which deepfake detectors can be used and combined with physical-based detectors to spot that the image is completely unreliable because they were synthetically generated and manipulated. And we also saw that the format analysis in the last case could reveal AI traces, okay? And we could also spot the manipulation. And I think it's important to note that the last case was very useful because we used a tool that is not explicitly designed for AI, to detect AI, but can detect any manipulation, AI-based or not, when the manipulation is done within two compressions. Okay? So can be used in several cases. So if you are thinking, do I really need all this technology? If you didn't make it yet, do it. The deepfake detection test. Try to visually detect deepfakes. And then if you get 20, yes, you are our expert. Okay. So thank you very much.